Hello everyone, my name is Preetham Ganesh and in this video I'll be discussing our paper titled Personalized System for Human Gym Activity Recognition. The presentation covers the following subtopics: abstract, introduction, contribution, proposed system, and the results. Machine learning plays a crucial role in almost every field. These days, many applications are being designed where machine learning is being used to assist users and help reduce their efforts. Data collected in a report suggests that nearly 40% of Americans suffer from obesity and 32% suffer from overweight. Another report suggests that this can be solved with the help of high muscular and cardiorespiratory fitness. This can be achieved with the help of proper food habits, sound sleep, and frequent workouts. The model proposed in this paper comprises a personalized system used to provide users the feedback on their performed gym activities. The feedback sent to the user consists of activity name, number of repetitions, and level of correctness at which the activity was performed. The model was developed for a single user per frame scenario. There are various works done by authors under the area of gym activity recognition. Most of these use wearable sensors for implementation purposes, which are obtrusive. However, the present proposed system is non-obtrusive. The proposed system comprises of the architecture shown in the figure. The modules colored in yellow are used only in the test training stage. The modules colored in blue are used during the testing stage. The modules colored in green are used during both the training and the testing stages. A total of 5 activities were used during the setup, which are push up, squat, plank, forward lunge, and sit up. A total of 4 male subjects were asked to perform the workouts in front of an RGB camera. The subjects had to perform 1 repetition of plank for 10 seconds and 15 repetitions of the remaining workouts. The features were extracted from the videos using the trained CNN called OpenPost. For this purpose, the video frames were resized from 1080p resolution to 480p resolution. The resized frames were fed into an OpenPost model to extract 18 schedule points, which are then converted into a comma separated file. The OpenPost model was executed on a 2019 13 inches Apple MacBook Pro with a CPU configuration of 8 Gen i5 and a GPU configuration of Intel Iris Plus Graphics 645. The average execution time is approximately 4 seconds per frame. The schedule points generated for each activity is shown in the figure. The converted CSV file consists of 37 columns. First set of 18 columns contains the X values of the schedule points in a video frame. The second set of 18 columns contains the Y values of the schedule points in a video frame. The last column contains the frame number of the video frame. Each tuple consists of schedule points corresponds to one frame. There were lots of missing values in the CSV files. It is mainly because only the right hand side of the subject's body was recorded and on the left hand side. Hence, the schedule points that belong to the left hand side of the subject's body were dropped. The remaining missing values were imputed using the data found in the corresponding column and the similar frame number of the subject's other workout videos. If values were found, then the mean would be the imputed value. If no value is found, then the mean value of the corresponding column in the current video is taken as the imputed value. The schedule points were normalized using min-max normalization. It was performed because the distance at which each user would perform the workout from the camera would vary. Also, the physical attributes such as total height and length of limbs would change with each user. The feedback was provided to the user with the help of an Android application. It consisted of 4 pages: a home page, a report page, a detailed workout page, and a settings page. A Django server was used for integration, and the Android application pings it for every 10 seconds to check whether the required results were available to populate. A repetition workout module was developed for splitting a set of classified workout tuples into different repetitions. A sample of the Y coordinate movement of the no schedule point in a push-up workout is shown in the figure. The correctness of workout module was developed to monitor the accuracy at which the user performs the workout. Subject 2 was a personal trainer and hence his data was used as a reference file for each schedule point. Since the speed at which each user performs a workout is different, a distance measure called dynamic time warping was used to compare it with the corresponding reference file. The value is calculated for each schedule point separately and is displayed in the AND application under the corresponding categories mentioned in the figure. The correlation between the schedule points and the activity was calculated using the Pearson correlation coefficient. The correlation heat map for the same is shown in the figure. It can be observed that the schedule points at nose, neck, right shoulder, right elbow, right wrist, right eye, and the right ear were negatively correlated with the activity. The other attributes were positively correlated with the activity. It is because of the location of the schedule points. The combined CSV file was fed into the following classification algorithms: decision tree classifier, support vector machine, k-nearest neighbor classifier, and a random forest classifier. The attempted models were validated using the repeated k-fold cross validation, where the number of folds is 10 and the number of repeats is 10. The performance of the classification algorithms in the combined CSV file is shown in the figure. It can be observed that the models have high performance in all the metrics. It can also be observed that the random forest classifier model produced an accuracy of 98.98%, a balanced accuracy of 98.98%, a macro precision score of 99.111%, a macro recall score of 98.35%, and a macro F1 score of 98.72%. The confusion matrix for the same model is also shown in the figure. It can be observed from the confusion matrix that the model recognized most of the workouts with a very high distinctive accuracy. It can also be observed that the push-up, plank, and sit-up workouts had minimal misclassification rates, and the squat had the lowest recognition rate of 97.6%. The result obtained on using the dynamic time warping on each subject's data versus the data from the subject 2 is shown in the figure. Each value in the table represents the mean value for the schedule point among all the videos. It can be observed from the table that all the values are non-zero, indicating that the model had a variety of data to train on. The difference could also be due to the change in height and length of limbs. These are some of the references from the paper. That concludes the presentation. Thank you.